interest, if they do give you a formula, I'm just going to show you what formula they're going to give you. If they do give you a formula, it will be A equals P bracket 1 plus I to the n. What does that look a lot like? The formula we did yesterday. The appreciating one, right? Okay, we're going to talk about compound interest here. So, compound interest, your mortgage, well, you don't have a mortgage, your parents' mortgage, if they have one, is in compound interest, which means it compounds semi-annually in Canada. That's the most they can compound it. What does compounding mean? So, if I have $1,000 and I put it into the bank, and at the end of the month it makes, let's say, $20 interest, okay? The next month, you're making interest off of $1,020. Because what compounding does is it takes the amount of money you just made in interest and it puts it in with the principal, the amount of money you put in. Okay? So now the next month, you're not making money off of just the $1,000. You're making money off of the $1,000 and the $20. And say you make $20.50 now. So the next month, you now have $1,040.20, and now you're making money off of that. So what happens when it compounds is, at the end of the compounding period, it takes what interest you made and it puts it in, and now the next month you're making interest off of what your principal is, what you put in, and the interest you made. Then the next month more. So, if you're actually making interest off of interest, it will grow faster, correct? So you want compound interest if you're investing money, because, and you want it to compound more frequently. So every month means you're going to get more money off of your interest, right? Mortgages, you don't want them to compound. Because what's happening is, at the end of the 6 months, whatever you still have owing, they make you pay interest on. And then they put the interest in with your principal and you owe more, right? Hopefully not more than what you had 6 months ago, because you are paying it down, right? But it still does cost a lot of money. So, for example, with an interest rate of 6% over 25 years on a mortgage, you will pay double what you went in for. So if your mortgage was for $206,000, at the end of your 25 years paying it off, you will have paid $400,000 for that house because of compound interest. Because the interest gets embedded back in, and now you're paying off interest. So your first few years of paying your mortgage down out of the 30 or 25 years is mainly just paying off interest. And then the closer you get to paying it off, the more principal you pay and interest. So compounding just means that at the end of that amount, your interest goes in, and now you're making money off your interest, or you're paying interest off interest, which is what you want to do. Okay, let's talk about compounding periods. There are a few different types they can talk about. So if they say monthly, monthly is how many times in a year? Sorry, I should say 12. If they say quarterly, it's always per year. How many times is that per year? 4. Every quarter, every season, right? So they would take every 3 months, you would take your amount of money that you made, it would go in with your principal, and then the next 3 months you'd make money off of that and the principal, right? Make that interest, it goes in, and it accrues money faster. And there's semi-annually. What do you think that is? How many times a year? Semi? Yeah, twice. Annually? Once. So those are the most common, right? So they often give you this formula APIN. The A and the P are different letters than what we use. We used F and we used I yesterday for final and initial. Okay? They use A and P, accumulated amount and principal. Accumulated amount means a fancy way of saying final amount. Principal means what you went in with. Final accumulated amount means what you come out of the bank with when you take out your investment. Okay? Do we care if these are A's, P's, F's, I's, N's, W's, smiley face, sad face? Do we care? No, we know that the number by itself on the left of the equal sign is your final amount, correct? The other one is your initial. It does not change. It doesn't matter what variable they give you. So could I go final equals initial 1 plus I to the n for this one? Yeah. And with compound interest, it always grows. Good or bad. Good if it's an investment, bad if it's a mortgage, right? You're paying interest off your interest. All right. Now, nothing changed. This is final amount. This is initial amount. This is n. The catch with n, though, is, and I, is your I is always per year, correct? Your interest rate's per year in decimal form. But we're going to have that interest compounding throughout the year, correct? So our I actually has to be the interest rate per compounding period. And our n is actually not just the number of years, it's the number of compounding periods per year. Times the number of years. Compounding periods, we'll just say compounding periods. So if we look at this first one, it says if you invest $500, what's that? Your capital I or your P, right? It's the initial amount. Yes? In an account paying 6% compounded semi-annually. What is our I? 0.06. But what? What's compounding annually or semi-annually? How many times is that? 2. So every compounding period, it won't be making 6% interest. Every compounding period, it'll be making 3% interest. Because you have to divide that by 2, right? Because it's compounding twice a year. So you're not making 6% and then 6%. You're making 3 and 3. So you take your interest rate, divide by 2. So every compounding period, I'm making 3%. Do you know what I mean? You make 6% the whole year, but we have to find out how much we make every compounding period. So you do I, your interest rate, divided by how many times it compounds a year. It compounded twice because of the semi-annually. Okay? So write an equation to represent this investment. Okay. Did we give us a final amount at all? No. So we can use A or F depending on what. If they give you a formula, you have to use the letter they used. Okay? So F equals, or if they used A, you have to use A equals 500 bracket 1 plus what? 0.03. And now it's not just to the n. It has to be the number of compounding periods. So how many times does it compound a year? 2. And then number of years is n. So I have to go 2n here. Because if it's a 3-year term, it compounds how many times? 6, correct? If it's a 10-year term, how many times does it compound? 20. It's 2 times the amount, right? We have to have the compounding periods, not the number of years when it's this. So our formula is F equals 500 bracket 1.03 to the 2n. Now in the next question it says estimate the value after 5 years. So where does that 5 go? In for n. So I'm going to get F equals 500 bracket 1.03 2 times 5. So instead of putting 2 times 5, what could I put here? Just the exponent 10. Do you agree? So type that into your calculator. Should it be more than 500 or less? More. Why? We're increasing, right? It's the nearest cent, so 2 decimal places. So I got $671.96. Now that's how much they walked out of the bank with. We agree? What if I asked you how much interest was made? Did they make $671.96 in interest? No. What did they make in interest? $171.96, because I have to take that $500 off. Because when she walked into the bank, she gave them $500, correct? And she let them sit for 5 years. And she went, I'd like to take out all my money. She takes out all her money and she walks out of the bank with $671. So did she make $671 in interest? No, she went in with $500. She gave that to them. Then she got to take $671 out. So she only made $171 extra from what she put in, right? So the interest, the amount of money that she made in interest was $171.96. It's 500 minus, or that minus. Okay. Determine when you would expect the investment to double. I'll do it on the next page because I won't have enough space. The investment to double. So what's my final going to be then? 1,000. Yeah, my initial is 500. My final is 1,000. I have 1.03 to the 2n. It's 2 times the number of years, right? What do I always have to do if I have my final and my initial? Divide them. Two equals 1.03 to the 2n. Now my exponent is stuck up there. The variable stuck in the exponent. What's the only way I can bring it down? Convert it to a log. So I get log base. The base of my exponent becomes the base of my log, so 1.03 with a 2 beside it. So friends doesn't say friends. And then it equals 2n. I'm going to have to divide by 2. We'll do to the nearest year. So I got 12 years. And then I box it and I'm happy, which some people on your test thought that that's actually real. I swear to goodness, I do this all the time. Sentence, yes. Yes, a delightful sentence, one might say. He missed it. Right, Carter? A delightful sentence. Yes. Actually asked me on the test if he writes a delightful sentence if he cannot lose marks, but he realized I need to take off the marks because the next one I'm going to annihilate people. It's a sad day in teacher world when you have to take off marks for sentences. Seriously. Sad day. You don't want to take off marks. So, it takes 12 years for the investment to double. Okay. Number 2. $7,000 is invested. So what's that? My initial. No. 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 I said no. I'm going to let it think about that. You guys try 2 and 3. So, for number 2, we have a $7,000 investment. I have to reset this. $7,000 invested. In a 6-year GIC. So that's going to be my N. But I have to take my N, my 6 years, and times it by what? 4. Why? Because it says quarterly. So actually, in 6 years, there will be 24 compounding periods. Because if it compounds 4 times a year, there are 6 years, that gives me 24 compounding periods. That's why I have to multiply those two numbers, okay? All right. At a rate of 5% per annum. So I'm going to have to go, what is my I going to be? Not 5%, 0.05 what? Divided by 4. Because I'm spreading that 5% out over 4 compounding periods per year, right? We have to remember when it says, people are like, how do I know it compounds? How do I know to use the compounding formula? Or how do I know to divide by CP for the I and times by CP for the N? It says compounded in the question. It will always say compounded. That's how you know to use it. So, 0.5 divided by 4, get 0.0125. So I'm going to get 1 plus 0.0125. And then they want to know what it will be in the final, right? They want F. So our interest rate per compounding period is 1.25%, which makes sense because it's 5% over the whole year. Then I split it into 4 compounding periods. Okay? So now I get final equals 7,000, bracket 1.0125 to the 24. Should it be more than 7,000 or less? Bless you. More. Why? We're adding interest. It's increasing. This is above 1. Remember? If that's above 1, we know we're increasing. If it's below 1, we know we're decreasing. So we get 9,431.46. The value of the investment at the end of the term is 9,431.46. Now 3. Find the interest rate. Yep.
What kind of question would it be to like find what you actually get? Or you like subtract the stuff?
When I ask you for the interest made. So this is the final amount. So this is the determine the value of the investment at the end of the 10 years. So if it's the value of the investment at the end of the term, that means what am I walking out of the bank with? So I'm walking out with 9,431.46. If I ask you how much interest did I make at the end, then you'd subtract and you'd say 2,431.46. All right. Number 3 wants us to find the interest rate. So we don't know I. The catch is we don't know I at all. But we know that I has to be divided by what? For this one. 4, because it's compounded quarterly again, right? So I is going to have to be divided by 4 when we fill it into the formula. Okay? So we have here, find the interest rate at which $3,000 invested, so that's my initial, $3,000 investment, compounded quarterly, 1 plus I divided by 4, will double in value. So we're going to get what here? 6,000 because it's doubling. And then our N isn't just N. What does it have to be? $4N. Because it has to be 4 times the number of years, right? Because it's the compounding period. It's how many times it compounds. Which you're right. Yeah. So it has to be 4 and then N. But what is N? 5. So it's going to be 4 times 5. Which I'm going to show that work. Which, yes, you're right by saying it is 20. But I like showing the work so we see that there's actually a 4 there. And there's a 4 here. And we're not just making up a random number. So now, when I have initial and final, we said the first thing we always do is divide that over, the initial over. So I get 2 equals 1 plus I divided by 4 to the 20. Do I need to get the exponent to pop down? No, I need to do something with the 20, but the variable itself is not in the exponent, correct? So I don't have to turn it to a log. I only have to convert to a log when I don't know the number of years. Other than that, I can just do normal math. And by normal math, I say normal math loosely, because we're going to be taking the 20th root, which isn't very normal. But how do I get this 20 to go away? I take the 20th root. And then those cancel, the 20th root. So I'm going to rewrite this as the 20th root of 2 equals 1 plus I divided by 4. Now the I divided by 4 is the last thing I can deal with. So what am I going to have to do next? How do I move a plus 1? Subtract. So now I have the 20th root of 2 minus 1 equals I over 4. Stop that smoking. Just kidding. Stop it. Okay. All the cigars. Cut 'em out. How do I get I divided by 4? Times by 4. And then we just type it into our calculator. How do we put in the 20th root of 2? Yeah, 20, math, 5. So typing it in, everyone's trying, because you guys rely on your other people, but no one's there for the test but you, on your test. So you have to do the 20th root of 2, hit enter, minus 1, enter, times 4. That's an insane interest rate. I'll take it. If someone gives me that, I'll hand them all my money. To 1 decimal place. So what's the interest then? 14.1%. And we're done. No. Yes. How you type it in? Yeah. So I would do this first and see the 4 last. So go 20 and then math, number 5. Next one. And then 2. Enter. And then minus the 1. Enter. And then times by 4. Did it work? So, the interest rate for the investment to double is 14.1%. All right. So compound interest is very close to like the appreciation formula. We just have to divide by the compounding periods for I and times the compounding periods for N. So like when I like looking at the formula, I will often do this. F equals I 1 plus I divided by CP to help remind myself. And then N times CP to help remind myself that I'm having to do those compounding periods. Right? Your I is never just I when it's compounded. Well, it could be. What would the compounding period have to be in order for your I to just be I? Yeah, 1. So it has to be compounding annually. Right? All right. This one is a bit different. It's a wee bit different. Okay? It's often when we talk about bacteria or we talk about radioactive material, stuff like that, that you want to grow exponentially or you don't want it to, but it still does, like bacteria, or you want to decay exponentially. So, the formula for this is different. I need everyone to pay attention. So it's going to be F equals I. That doesn't change. You could label them sad face and smiley face for all I care. Final is first, initial is next. Okay? That didn't change in any of the 3 formulas, did it? The difference here is I want everyone to put their pencils down and pay attention to me, because I want you to understand why the formula is the way it is, not try to memorize it. I'll pick that up in a second. All right. I told you if this class doesn't change, what percent is of the class? 100%. And as a decimal, it's a 1. Correct? So if this class stayed exactly where we are, what size we are, no one decreases, no one increases, we're at 100%, which is 1. We agree? Okay, what if I tell you that the class doubles? What percent would we be at? 200. Is that true? So what is that as a decimal? 2. Right? What if I said we tripled? We would go from 100 to 300, and what would that be as a decimal? 3. Okay? What if I said we halved? All of a sudden, instantly, half of you left. You'd be so sad. You'd be at 50%, or 0.5 as a decimal, or a half as a fraction, correct? So, these ones are all doubling, tripling, or half-lifing, correct? So in here, I put an R, but I technically could put I times whatever the heck it is. So, if it says it doubles, what do you think this number is going to be in this bracket? A 2. Why? Because it's 200% instead of 100%, right? So I'm multiplying now, not adding 10% or adding 12% or adding 14% or adding 4.5%. I am doubling 100%. So I'm going to get to 200%, which is a 2, right? What if it said it triples? We're going to have a 3 because it's now what percent? 300%, correct? And what if they say the word half-life? It's going to be a half. You could use actually a half, or you could use 0.5. And then N, oh sorry, and then it's T over P, which is confusing, and I'll explain that as well. T over P. Now the hardest part is to remember what the heck T and P are. So once you have that written down, set it down. Set down your pencils, because I need you to pay all the attention. Okay? It's not a hard concept, it's just that people don't get the concept because they get a little sidetracked. So we're going to pay close attention, okay? The T, you can write this after, don't pick your pens up. I will give you time to write this, I promise. T is time to reach final. Don't write this. I will give you time. So it's the time to reach final. So what the heck is that? Well, that's to say, okay, I placed 2 bacterial cells in a petri dish. And in 10 years, or it's less than bacteria, it's crazy. In 10 minutes, there's 1 million bacteria. Okay? That 10 minutes is the time to reach the final amount I gave you. 10 minutes to reach 1 million bacteria. Do you know what I mean? So if I said radioactive material, there's this radioactive material, and it takes 5 years to get down to 0.1 grams. 0.1 grams would be my final, and 5 would be, what? The T, because it's time to reach final, okay? The other way to figure out if it's T or P, P is the period. So a period of something is a cycle of something happening, correct? So if I say that it takes 10 minutes to half, that means every 10 minutes, I'm going to have half of what I had the 10 minutes previous. Then half of that, then half of that, then half of that, then half of that, every 10 minutes, correct? So that's the period. The period is how long it takes to half or double or triple, okay? So if I say it halves every 10 minutes, P would be 10, okay? If I say it triples every 15 minutes, P would be 15, because every 15 minutes I would have triple of what I had the previous 15 minutes, and the 15 minutes, and the 15 minutes, okay? So T is time to reach final, and the P is how long to double, triple, or half. You can write these. Often the period falls after the word half-life or doubling or tripling. So they'll say it triples every 10 minutes. It doubles every whatever. If the word triple, double, or half-life is in the question, they're often asking for the period. How long does it take to double? How long does it take to triple? Then they're asking for the period. So let's look at this first one. Let's get those written down. A lab tech placed a bacterial cell. How many cells is that? 1. So that'd be my initial, right? A bacterial cell. Into a vial at 5 a.m. Cool. Don't really care. The cells divide in such a way that the number of cells doubles. What does that give me? Doubles. Actually gives me R. What's my R? 2. It doubles every 4 minutes. What does that give me, which is what you guys were already on to? P. If it doubles every 4 minutes, in 4 minutes, I'm going to double. In 4 minutes, I'm going to double. In 4 minutes, it's going to double. In 4 minutes, it's going to double. In 4 minutes, it's going to double. That's the period, right? How long it takes to double. So that's the P. How long does it take for the cell to divide to produce 4096? So what's this 4096? It's my final. And how long to produce that? What are they making me find? T, time to reach final. We agree? So I'll do it here. So we go 4096 equals 1, bracket 2 to the T divided by 4. Now T and P have to be in the same unit. So if like T is in minutes, P is in minutes. So since P is in minutes, we know that T is going to come out in minutes, correct? All right, I have final and initial. So what's the first thing I'm going to do? Divide. First, divided by 1 does nothing, but I'm doing it anyway. Divide by 1. So 4096 equals 2 to the T over 4. The exponent is where the variable is. I'm going to have to log, I'm going to have to log, I'm going to have to log, right? It's the only way I can get that exponent down. So I'm going to have to convert it to a log. So I get log base what? Log base 2, because it's the base of my exponent. But friends doesn't say friends, so what do I get beside it? 4096 equals T over 4. Then what am I going to do? Times by 4. Come on, join me. Then T is going to be in minutes. "48 minutes. And then we're done, obviously. Sentence. It takes. We're going to have this in your nightmares. You'll be like doing math, and then all of a sudden you'll hear me screaming sentence at you. Sentence! It's a right response. Okay. It takes 48 minutes for the cells.
Everybody, the day of the test when you come in, I will have sentences. I'll just remind everybody.
To divide, to produce. She's going to get a tattoo on her hand that says sentence. I want these done for tonight, 2, 3, 4. We're going to go through them at the beginning of class, plus that one from yesterday, the one where I made you do the writing. Yeah, do not lose that, or if you haven't done it, do it.